Hey guys, my name is IBM and I'm still solving FEB paper 4. This is component 4.2, physics 9702. I think this is going to be part 4 and I want part 4 to be questions 7 and 8. Okay, state Faraday's law. Faraday's law, of course, there are two laws of electromagnetic induction. We have Faraday's law and Lenz's law. As Faraday's law talks about the magnitude of the induced EMF, Lenz's law talks about the direction of the induced EMF. So for Faraday's law, the magnitude of the induced EMF is directly proportional to the rate of change of magnetic flux linkage. So simply say magnitude of induced EMF is directly proportional to the rate of change of magnetic flux linkage. That is Faraday's law of electromagnetic induction. A metal rod is excited uniformly from rest in a uniform magnetic field as shown in the figure. So the field is uniform. Okay. The rod has length L and the flux density of the magnetic field is B. Because it is accelerated from rest means the initial velocity could be 0, and it is accelerated in uniform, it means the equations of motion can apply, such as V equals to U plus AT. It's accelerated uniformly, the equations of motion can apply, such as V equals to U plus AT, and since it starts from rest, it means the V could be equal to A times T, because the initial velocity is 0. An EMF is induced in the rod. The variation with the time t of the induced EMF is shown here. Okay. Explain how the figure shows that EMF is directly proportional to the velocity of the rod. Okay, so like I've said, for uniformly accelerated, velocity is equal to U plus AT, which means, and of course we know that it started from rest, initial velocity was 0, so V is equal to A times T, which means that the velocity is directly proportional to T. Also, we know that the induced EMF E is equal to the rate of change of magnetic flux linkage, which is going to be change in phi over T, but of course we know that phi is equal to B times A, which means if it moves through a distance, the rod has length L, that means cross-sectional area is going to be the cross-sectional area is going to be L times the distance through which it moves, or the cross-sectional area, or the area through which the rod sweeps, is going to be length of the rod times the distance through which it moves. So the area through which the rod moves is going to be L times the distance through which the rod moves. So this is the area through which the rod sweeps. That means that the induced EMF is going to be equal to BL times X divided by T. Not forgetting that X, the distance through which the rod moves over time, is equal to the speed of this. This means that the induced EMF is the same as B times the length of the conductor times the speed with which the conductor is moving, which means that E is directly proportional to V. Now we have that V is directly proportional to T, and E is directly proportional to V. So if E is directly proportional to V and V is directly proportional to T, it implies that E is directly proportional to V. So here I said V is directly proportional to T, and E is also directly proportional to t from the graph. We see that E is directly proportional to t. This one means that E is directly proportional to V. Alternatively, I have just shown you this to show that E is directly proportional to V. But since they said explain how the figure shows that E is directly proportional to the velocity V, so I will just concentrate on this because from the figure, it is a straight line which shows that E is directly proportional to T, and yet we know that V is equal to U plus AT, so V is directly proportional to T, which means that E is directly proportional to V. So we shall say that uniform acceleration implies that the velocity is directly proportional to time from that equation. Uniform acceleration implies that velocity is proportional to time. So because there's uniform acceleration, equations of motion apply, initial velocity is 0, so V is directly proportional to time. And then the figure shows that E is directly proportional to time. The figure also shows that E is proportional to time. Hence, E is proportional to V. This is very simple. If we consider the motion as being uniformly accelerated, we have seen that V was directly proportional to time. When you look at the graph, it is a straight line through the origin, which means that E is directly proportional to T, and thus E will be directly proportional to V. Alternatively, you can think about this, even though this is not required for this question, but I just wanted to show you that E was directly proportional to V because V is a constant, and the length of the conductor is also a constant. Use Faraday's law to show that the variation of E with the time t is given by E equals to BL at t. Okay, so still this is uniformly accelerated. So we have already said that V equals to U plus at, and we saw that U was equal to 0. So we already saw that V is equal to A times t. And the distance moved in time, let's say delta t, is going to be equal to, so distance moved in time, which I'm going to call delta t. Of course, is going to be the speed v times the time delta t, which is going to be, the speed is going to be at, then times the time, which is going to be delta t. And we know that magnetic flux is equal to BA. Flux is equal to BA. And also we know that the electric field strength E is the rate of change of magnetic flux. So it means E is going to be equal to B times A, where A is going to be equal to the distance, the length of the conductor times the distance through which it moves, which is going to be x. Then this is divided by the time delta t. But remember, they say the distance is going to be at times delta t. So this is going to be B into L times, where the distance moved in the time delta t is going to be at times delta t. then divide this by delta T. And that means that induced EMF is going to be B L times AT, because delta T will cancel out. So that is as required. Alternatively, that is not the only alternative. I could use a simple or simpler method, which is quite more direct. So by definition, we know that induced EMF is equal to the rate of change of magnetic flux linkage. And we know that magnetic flux is equal to BA. And we know that the area swept through by the conductor is equal to the length of the conductor times the distance through which it moves. Therefore, it means the induced EMF E is going to be B times X times L divided by the time delta T. But X divided by the time delta T is equal to the speed V. Distance over time is the speed, and we know that speed V is equal to U plus AT, and of course U was equal to 0. So it means the speed V is going to be equal to A times T. Therefore, it means that the EMF E is B times V times L, which is the same as B times AT times L. Hence, EMF is simply going to be B L times AT as required. Okay, so that is another method. It's almost the same, but simple reasoning. The length of the rod is 0.45 meters. The acceleration A of the rod is 7.8 meters per second squared. Determine the value of B. So we're just substituting into E equals to BL times AT. So we want to find B. They've given us the acceleration, so I'll just divide this E by T. This is going to be BL times A. Which this means that B is equal to E over T times 1 over LA. So they have given us the length as 0.45. They have given us the acceleration, and E over T could be the gradient or a value from the graph here. I will just take 2 and 0.3 from the graph, or you can take the gradient. So this is going to be 0.3 times, I think it's times 10 to the power of minus, this is millivolts, so 10 to the power of minus 3 over the time, which was 2 seconds, times 1 over the length is 0.45 times the area, the acceleration, which is 7.8. So we have 0.3 exponent minus 3 divide by, open brackets, 2 times 0.45 times 7.8. So that is 4.27 times 10 to the power of minus 5 Tesla. So the answer here is approximately 4.3 times 10 to the power of minus 5. State what is meant by a photon. So that is now quantum physics. Of course, a photon is a packet of energy of electromagnetic radiation. A packet of energy, or a quantum of energy of electromagnetic radiation. So a photon, this is going to be a packet, or you can call it a quantum of energy of electromagnetic radiation. And of course, we know that the energy is equal to Planck's constant times the frequency. I always encourage my students to write as much details as possible as long as they have time to already score full credit. A laser emits red light of a single wavelength, so it's monochromatic. Light is produced when electrons move from a higher energy level to a lower energy level. That is a transition. The difference in energy between the two levels is 1.96 electron volts. So that means the change in the energy is 1.96. Catch the wavelength of the light emitted. So the change in the energy levels is equal to hc over the wavelength. Or the wavelength is going to be equal to the change in the energy divided by, it is going to be hc. The wavelength is going to be hc divided by the change in the energy. Of course, we know that 1 electron volt is 1.6 times 10 to the power of negative 19 joules. So this is going to be equal to H is 6.63 times 10 to the power of minus 34. Then C is the speed of light, which is 3 times 10 to the power of 8, divided by the energy change, which is 1.96 times 1.6 times 10 to the power of minus 19. So we have 6.63 exponent minus 34 times 3 exponent 8 divided by 1.96 times 1.6 exponent minus 19. So that is 6.34 times 10 to the power of minus 7. I'll just write 6.3 times 10 to the power of minus 7 meters. The power of the beam emitted by the laser is 1.0 times 10 to the power of minus 2 watts. Calculate the number of photons emitted per unit time. Number of photons emitted per unit time. So number of photons emitted per unit time. So we know that power equals to energy divided by time. But total energy is going to be the number of photons times the energy of each photon, or times the change in the energy. Divide this by T. Because this is just for one photon that we have above there. So it means we want to find N over T. So making N over T the subject is going to be the power divided by the energy of just one photon. So this is total energy. So this is going to be the power, which is 1.0 times 10 to the power of minus 2. And the energy of just one photon is 1.96 times 1.6 times 10 to the power of minus 19 to change it to joules. This gives you 1.0 exponent minus 2 divided by 1.96 times 1.6 exponent minus 19. That is 3.19 or 3.2 times 10 to the power of 16. So I'll write here 3.2 times 10 to the power of 16 per second. The photons are incident normally. that is perpendicular on the surface. Half of the number of photons are absorbed by the surface. Half of this is going to be 1.6 times 10 to the power of 16. These ones are absorbed. And half are reflected. So 1.6 times 10 to the power of 16 are reflected. Of course, if they are reflected, then it means they have, because they are incident normal, if they are reflected, we assume that the collision is elastic. So they are going to be reflected with the same momentum in the opposite directions. Determine the average force exerted by the beam of photons on the surface. So let's say this is the surface. Half of these particles arrive on this with a momentum p, and then the final momentum becomes 0. So then half of them come with a momentum p, and then they are reflected in the opposite direction with a momentum which I'm going to call negative p, because they are incident normally. We expect that they rebound and they reflected in the opposite direction normally. So they could be reflected with the same momentum. Okay, so determine the average force. So there are two ways I'm going to do this. So half of the particles, half of the photons have change of momentum, which is going to be p. So half of photons each have change in momentum as p minus 0, because they are absorbed. So that is p. Total momentum will be the number of particles times p. And half, this was each, and half each, half of photons each has, let me say half of photons each has change in momentum as p minus negative p, which is equal to twice p, which means the average change in momentum of each particle. So the average change in momentum of each is going to be p plus 2p divided by 2, which is going to be 3p over 2. That is the average, which means that the total change in momentum, for all is going to be equal to 3 over 2p times n, or number of particles, which, and we know that force equals to change in momentum over time, then times the number of particles. So the force is going to be equal to change in momentum. Total change in momentum is going to be 3 over 2 times the momentum of one particle, which is 1 point. What is the momentum of one particle? What is the momentum of one particle? Momentum of one photon. Okay, times the momentum of one photon, then times the number of photons, which is what, 3 point, the number of n over t, which is 3.2 times 10 to the power of 16. N over t is this. So we know that p, momentum of one particle, Momentum of one particle, we know that momentum of one particle is energy of the particle over the speed of light, which is going to be 1.96 times 10 to the power of, times 1.6 times 10 to the power of minus 19. That is the energy divided by 3 times 10 to the power of 8. So this is going to be 1.96 times 1.6 exponent minus 19 divided by 3 exponent 8. So one particle is 1.05 times 10 to the power of minus 10.7 Newton seconds. So that means that the average force is going to be 3/2 times 1.05 times 10 to the power of minus 27 times 3.2 times 10 to the power of 16, which is equal to, so 1.05 exponent minus 27 times 3.2 exponent 16 times 3 divided by 2. So I'm getting 5.04 times 10 to the power of minus 11, or 5.0 times 10 to the power of minus 11 Newton second, or newtons. That is method 1. I'll use a very easy method, but I don't have space. Where should I do this? I'm looking for a blank page. I didn't add blank spaces in this document, so I'm going to use this space here for the alternative method, which is very easy to understand. So first of all, I will get the momentum of one photon. So I'll say momentum of one photon. The momentum of one photon, P, equals to the energy divided by the speed of light. We have said energy was 1.96 times 1.6 times 10 to the power of minus 19 to change it to joules, divided by 3.3 times 10 to the power of 8. And this has already given us 1.05 times 10 to the power of, was it, minus 27 Newton seconds. That was momentum of one photon. Then for particles absorbed, we can find the force exactly. Remember, force equals to the change in momentum over time. So for particles absorbed, the force is going to be equal to the change in momentum over time. So this is going to be the number of those particles. I'll use N absorbed times the change in momentum, which is P initial minus P final, divided by T. The number of particles absorbed per second is half, which was 1.6 times 10 to the power of, because total number of particles per unit time was 3.2 times 10 to the power of 16. So those absorbed was half, which is 1.6 times 10 to the power of 16. This is N over T. Then change in momentum, because their absorbed final momentum is 0. So the initial momentum is just P, which is 1.05 times 10 to the power of minus 27. And this gives us 1.6 exponent 16 times 1.05 exponent minus 27. So this is giving us 1.68 times 10 to the power of minus 11. 1.68 times 10 to the power of minus 11 newtons. Then for particles reflected, the force exerted, this was absorbed, this was reflected. This was absorbed. The force is going to be again change in momentum, which is going to be the number of particles reflected over time. Again, final or initial minus final momentum. This is going to be equal to the number of particles reflected is 1.6 times 10 to the power of 16 because that was half. Then the final, the momentum was P minus negative P because we assume that the collision is elastic. The second minus is because reflected means in opposite directions. So P minus negative P, which is the same as having 2P. So it becomes 2 times 1.6 times 10 to the power of 16, then times P, which is 1.05 times 10 to the power of minus 27. So I just have this times 2. That is 3.36 times 10 to the power of minus 11. So this is 3.36 times 10 to the power of minus 11 newtons. So it means the total force is just going to be 1.68 plus 3.36 times 10 to the power of minus 11. So 1.68 plus 3.36, that is 5.04 times 10 to the power of minus 11 newtons. Therefore, the total force is again 5.0 times 10 to the power of minus 11 newtons. Okay, so that is question 8. See you in the last part of this paper, which will be part 5. Bye bye.